This video is just going to provide one more representation of the dot product. And so what you see here are two vectors, vector u and vector v, and we're going to compute their dot product. And what I'd like you to do, just treat it just like the same Mario Kart example that we had before. There's our booster, and it has a magnitude, this will say a magnitude of 9, vector u. Vector v, let's pretend that's our cart, and we'll say it has a magnitude. Right now at the moment that's 14. Let me go ahead and make that back to a value of 15 if I can. Slide in a little bit, see if I can get away with that. So you can see the magnitude values up here a little bit. So here's what we'll go ahead and do. I'm going to start moving these closer and closer. At the moment, I'm getting no benefit, no boost. And we'll pretend that this vector does what? It increases your speed by a factor of 9, let's say. And so the magnitudes we can use as representing speed. We'd say the dot product right now is 0 because these two angles are perpendicular. If my cart's going this way, it gets no boost, no change in the speed, the vertical speed, so to speak. Now, as I start to move vector v, I'm going to try to keep its length around 15, but just based on how I do this, it's not going to be perfect, so just kind of bear with me. The dot product starts to take on a value. You can see it takes on a value of, it's a little bit hard to see here, of positive 45. Let's see if I move the screen, if you get a little better view. Not too bad. I'll keep sliding this vector, so it's becoming what? A little bit more parallel each time. The dot product continues to increase. It's now up to 63. My vector's a little bit shorter, but again, remember, just as I roll this thing through, I'm not going to be able to keep vector v at that same size, just as I roll through these different points. But what do you notice? The dot product is continuing to increase. I'm all the way up to a value of 90. And my angle in here, it's a little bit hard for you to see, but it's about 47 degrees right now. As these angles get closer and closer, what do I notice? My dot product is now at about 108. Let's keep going, get closer and closer. I'm going to try to make this thing back to about a 15 again. So two vectors just about the same size as when we started, when they were perpendicular to each other. Look at our dot product now, 126. That would kind of be what? This speed with that 9-factor boost. It's getting closer and closer until what happens when I get to the stage where they are essentially perpendicular. Take me a couple more moments to do that. Pretty good representation. My dot product's at 135, which is really what 9 times 15 happens to be. That angle has gotten ridiculously small now. Even smaller. Dot product's, hanging at 135. Again, my size is going to change a little bit. But what am I noticing here? When the two vectors are essentially parallel to each other, the angle in between them is what? It's going to approach and it will eventually reach 0. The two magnitudes, 9 times 15 times the cosine of the angle in between, well, that angle in between is going to get closer and closer to 0, which is going to be a value of 1 for its cosine. I get the full benefit. And there's a perfect example of that again. Take my vector 15, 9 times 15 times the cosine of 0 is 135. I'm getting the full boost at the moment. Now there's one other thing to talk about. What happens when my angle becomes, this is really what? A negative angle between these two vectors now. And so what will we start to see? Over time, watch what I do. I'm going to make the angle between them, look, it's no longer parallel, it's obtuse. My dot product has now become, and again, I'm sorry that's a little bit hard to see on the screen, it's actually become a negative number. And again, watch what happens when the lines become, or the two vectors become perfectly parallel to each other. You'll see that they change. The dot product becomes zilch. And I won't be able to get this quite there. There's 180 degree, and you'll see. So the bottom line is, just remember, the dot product is just really kind of a visual mathematical, it's a number, it's a scalar. Dot product always gives you a number, not an angle, anything of that nature. And it really just represents the relationship, the interrelationship amongst their respective magnitudes. The closer together, their magnitudes work just about in full concert. What did we see? When they're parallel. two magnitudes, in this case 9, 7, just because of how I stretch that, times the cosine of 0 times 1. full benefit. The 9 and the 7 are working together as best they can. 9 times 7 creates 63. As soon as I start to separate them, what starts to happen to my dot product? It starts to go down. Because why? The cosine function, as you go from 0 degrees to 90 degrees, that function gets smaller and smaller. What do we really use the dot product for? Not so much to understand this raw number, but really it just helps us understand it's a way of representing and solving for the angle between two vectors. And we'll work through that with some of the problems in this unit as we talk about the dot product.